Hi guys, hope you're doing well. We are starting subunit 4.5 today. This is about trigonometry, and the notes for it were posted yesterday, so please make sure you're taking a look at those. Trigonometry is defined as the study of triangle measurement. So let's break that down. Gon sides, right? Like polygon, many sides. So trigon, 3 sides, and then metry. So like metrics, right? It's literally just the study of triangle measurement. And trigonometry is a huge body of study within mathematics. Some schools have entire year-long courses dedicated to trig. In Math 3, you're going to be spending quite a lot of time diving into trig functions, like how they're graphed. But all we're doing together this year is just the 3 basic ratios and how you can use them to find missing side lengths and angle measurements in right triangles. So this only works in right triangles. So it's really, really important, all right? And we have 3 trig ratios: sine, cosine, and tangent. And I know that those are brand new words to you, but I don't want you to let yourself get overwhelmed or confused. They're actually really, really straightforward, right? All sine is the ratio of the leg opposite a given angle to the hypotenuse. So if we're talking about angle A in this example right here, all right, the ratio of the leg opposite of it is this one, CB. That's its opposite, right? And then the hypotenuse is AB. So we have the opposite leg here, that's A, to the hypotenuse, which is C. So the sine of angle A is A to C. The sine of angle A is going to be different than the sine of angle B because angle B has a different leg that's opposite of it. So opposite of angle B is side B. Of course, the hypotenuse is the same. Every right triangle just has one hypotenuse. So the sine of angle B is B to C. Next, we have cosine. Cosine is the ratio of the leg adjacent to the given angle to the hypotenuse. So adjacent to hypotenuse. So if we're talking about A, the leg that's adjacent to A is B. Remember, adjacent means it touches the angle, right? So our options are B and C, but C is the hypotenuse, so it's not a leg, all right? So B is the leg that is adjacent and C is the hypotenuse. So the cosine of A is B to C. Go ahead and take a second and try to think on your own what the cosine of B is. Pause this if you need to. All right, the cosine of B is C. Oh, I'm sorry, it's not. It's A to C. All right, A being the leg that is adjacent and C being the hypotenuse, I'm sorry. Lastly, we have tangent. Tangent is the ratio of the leg opposite the angle to the leg adjacent to the angle. So there's no hypotenuse here. It's opposite to adjacent. So if we're talking about A, opposite of A is leg A, and adjacent is B, not C, because C is the hypotenuse, and that's not involved in tangent. All right, so we have A to B. Next, we have tangent of angle B. So opposite of angle B is side B, and adjacent is side A. So B to A. If you are like, wait, what just happened? That was a lot. You are not wrong. That was a lot. So go ahead and stop this and rewind and watch that again. And watch it as many times as you need to until you get it. So there's a really easy mnemonic device that we use to remember all of this. It's called SOHCAHTOA. So, S-O-H. And I do the O and H like that instead of like this because I think it helps you remember that the O is above the H, meaning the ratio is opposite over hypotenuse. Ka. So you have cosine, and that is adjacent. Oh, goodness gracious. Adjacent over hypotenuse. And then you have tangent, and that is TOA, because tangent is opposite over adjacent. So we are going to try one of these. We're going to try number 1 together, all right, where we are just giving the ratios, and then on the next page, we are going to use the ratios to solve for missing side lengths. And tomorrow we're going to solve for missing angle measurements. All right, so all we're doing is just looking at the angle in question. So for example 1, we're talking about angle A and angle C, not angle B, because angle B is the right angle, right? So that one is not one of the ones that we'd be looking for the ratio for. So when we're looking for angle A, what I recommend doing is on your drawing, in some way, like illustrate that you're talking about A, and then mark up what all of the sides are in reference to A, not to C, just to A. So in reference to angle A, 5 over here is opposite, so just put a little O next to it. 12 is adjacent, and 13 is the hypotenuse. That's, of course, not going to change. That's no matter what angle you're talking about in that triangle, 13 is the hypotenuse. But the opposite and the adjacent are all relative based on the angle you're talking about. So you're able to complete sine, cosine, and tangent for A without having to find the opposite, the adjacent, and the hypotenuse each time. So sine of A, sine, so, opposite over hypotenuse. So sine of A, opposite is 5. Hypotenuse is 13. That's really all there is to that. Cosine is ka, adjacent over hypotenuse, so that is 12 to 13. And then tangent, TOA, opposite over adjacent, so that is 5 over 12. So I think marking it up really, really helps, and I strongly recommend that you do that. All right, go ahead and draw the same diagram again, but highlight angle C, and then mark up everything in respect to angle C. So 12 is no longer adjacent, now it's opposite. 5 is now adjacent. 13, as we said, that's always going to be the hypotenuse. So sine of C, sine, so, opposite over hypotenuse, 12 over 13. Cosine is so ka, so adjacent over hypotenuse, 5 over 13. And then tangent is opposite over adjacent, TOA. So opposite is 12 and adjacent is 13. Oh, I'm sorry. Adjacent's not 13, adjacent is 5. Again, if you need to see it again, stop, rewind, watch it again. So we are now going to use these ratios to find missing side lengths. So you all are going to need your calculator out, not a 4-function calculator, you need a scientific calculator. And this is something that I really wish we were doing in person, but alas, it is what it is. So I really need you guys just to stay with me here and make sure you're paying attention. So we are solving for x. And the way that you're going to do that is you are going to take a look at the triangle and pinpoint the angle that is relevant to you. It's never going to be the right angle. It's going to be one of your two acute angles, so one of the other ones. And the one that's relevant to us is going to be the one that we have information about. So this one is the one that's relevant to us. And then we are going to identify the sides that are relevant to this angle. So the two relevant sides are obviously the ones that we, again, have information about. We don't have any information about the one, like this one, right? So that's not relevant to us. But we know that across from it is x, so I'm going to ask, is that opposite, is it adjacent, or is it hypotenuse? It's opposite. And then the other one we have information about is the 19. That is the hypotenuse. This one down here is the adjacent, but that's, again, not relevant to us right now, so you don't have to write that. You can if you want, but it's not important. Then you ask yourself, okay, so I have the opposite is x, and I have the hypotenuse is 19. So then you go to your three ratios, sine, cosine, and tangent, and you say which one deals with opposite and hypotenuse. So if you want to write SOHCAHTOA up here, do that. Looking at that, I can see that sine is my ratio that deals with opposite and hypotenuse. So we are going to write sine of 28 because we remember on this page we said sine of the angle, sine of A, right, equals whatever the ratio is. So here we know the measurement of the angle. The angle is 28 degrees. So sine of 28 equals opposite over hypotenuse. Opposite is x, that's what we're finding, over hypotenuse is 19. And from there, you just cross multiply. So sine of 28 is sine of 28 over 1, right? Anything can be a fraction, just put it over 1. So you have x times 1, x equals 19 times the sine of 28. So in your calculator, you literally just do 19 times and then look for the function that says sine, put 28, and hit enter, and we're rounding to the nearest tenth, so you're going to get 8.9. So that's the value of x, it's 8.9. And before you say that you're done, you've moved on, it's really easy to make mistakes here, especially when you're just starting this. So make sure that the answer that you're getting is reasonable. Make sure that because it is one of the legs, not the hypotenuse, that it is shorter than the hypotenuse, right? So it has to be shorter than 19, but it's also not like a ridiculously small number. So you just need to be kind of checking for reasonableness there. All right, we're going to do two more. Let's try number 2. So again, the order of operations here. Number 1, you identify your angle. This is the angle. Number 2, you identify your sides in relation to the angle. All right, so the two relevant sides to us here are the x and the 32. The x is opposite, the 32 is adjacent. The blank one there at the bottom is the hypotenuse, but that is not relevant to us right now. Next, you are going to determine the ratio. So, which ratio involves opposite and adjacent? Tangent. So, tangent of 41 equals opposite, which is x, over adjacent, which is 32. Again, we're going to cross multiply. X equals 32 times the tangent of 41. Same thing in your calculator. 32 times the tangent function, 41. And x is going to equal 27.8. before we say we're finished, you need to check for reasonableness. We don't know the hypotenuse, right? So we can't say, oh, it's smaller than the hypotenuse, but the other leg is 32, so it makes sense that this is 27.8, right? It's not like a ridiculously small or bigger number. Let's do one more, but I don't want to do number 3. I actually want to do number 6, and you'll see why in a second. So first step, identify the angle. Second step, the sides in relation to the angle. So the 36 is the adjacent side, and the x is the hypotenuse. All right, looking at our ratios, the one that deals with adjacent and hypotenuse is cosine. So cosine of 43 is, so it's really important here. Don't always just put the x in the numerator, all right? Cosine is adjacent over hypotenuse. Adjacent is 36 over the hypotenuse is x. Pause and rewind that if you need to, all right? But again, the x isn't always going to be in the numerator. You have to stay true to the ratio. Cosine is adjacent over hypotenuse. Adjacent is 36 over the hypotenuse, which is x. But you still cross multiply, right? The only difference is x isn't in the numerator this time, but it's really not changing much, all right? You cross multiply and you do 36 equals x times cosine of 43. All you have to do here to solve for x is just divide both sides by the cosine of 43. So instead of multiplying it by something, in this case, it's just being divided, right? So 36 divided by the cosine of 43 is going to give you 49.2. And we can check for reasonableness here. That is the hypotenuse. So is it longer than the side that we have? It is. All right. So that is all for today. I know it was a lot. Please, if you feel like I don't know what just happened, I need you to rewatch the lecture as many times as you need. I need you to try and like really pay attention and try to piece this together. If you are having any confusions or questions, please reach out to me. Like, this is not something you should be putting off until tomorrow, because tomorrow we are adding on. And I'm happy to hop on the phone or on FaceTime and explain it in more detail if that's what you need. So yeah, please just make sure that you are you're getting this as much as you possibly can, and you are working through the IXL. It's okay if it's not perfect. I just need you to do your best, and let me know if I can help you in any way. All right. Okay, I'll talk to you guys tomorrow.